day, students. So we'll be treating this very interesting topic called bearing and distance. So bearing and distance is one of the applications of trigonometry, meaning when you say trigonometry, it has to do with mensuration concerning triangles. We know a triangle to be a three-sided plane shape. So with three angles as well, with the total sum of the angle being equals to 180. And a triangle can have all its sides equal and called equilateral. Then we have triangles with just the two opposite sides being equal. That is, only two sides are equal. We call the isosceles. Then we have that triangle that has none of the stereo sides equal. We call such this scaling triangle. Then we now have a triangle we call the right angled triangle. So this right angled triangle could fall into any of the um, into either scaling or isosceles. But what is important is that it, it has one of its angle equals to 90 degree. One of its angle is equal to 90 degree, and that angle we call it right angle. So usually in such a triangle, you have a vertical and a horizontal line meeting with the third side. So this is why we have the angle 90 degrees. We call this kind of triangle a right angle triangle. And whenever we have a right angle triangle, already we know one of the angles is 90. Then we have the other two angles to make up the remaining 90. So if our angle of interest is theta, then the side opposite this angle will be said to be the opposite side. And the longest side, which is usually the side facing the right angle, is referred to as the hypotenuse side. And then the side adjacent to the right angle or to the angle, then we call it the adjacent side. So these are the three sides in the right angle triangle. And then we have this trigonometry with respect to the right angle triangle, that if you take the sine of this angle, then it is equals to the opposite all over the hypotenuse side. Then the cosine of this angle will be the adjacent over hypotenuse, the adjacent over the hypotenuse. And the tangent of this angle will be what? The opposite over adjacent. Opposite over adjacent. So this is important. What we call, usually called SOHCAHTOA. SOHCAHTOA. So when it is sine, it is opposite over hypotenuse. When it is cosine, it is adjacent over hypotenuse. And when it is tan, it is opposite over adjacent. So if it were sine alpha, it would be this would become the opposite. This would be the hypotenuse. Then as so on and so forth. So this is important. Another thing that needs to be known in the trigonometry of a right angle triangle is the Pythagoras theorem. The Pythagoras theorem. The Pythagoras theorem. So which states that the square of the longest side, which is the hypotenuse side, is equals to the sum of the squares of the other sides. That is the square of the opposite plus the square of the adjacent. So which means if you add the square of these two sides, then they should always be equal to the square of the longest side, which is the hypotenuse side. For instance, if this is 3, let's say 3 centimeter, and this is 4 centimeter, then the hypotenuse side will be 3 square plus 4 square, which gives 9 plus 16, giving 25. So that would be the square of the hypotenuse, so which makes hypotenuse equals the square root of 25, giving 5. So meaning hypotenuse is 5. So by the time you take the square of 5, it should be equal to the square of 3 and square of 4 added together. So this is important. Then still other trigonometry, there is what we call the sine rule. The sine rule and the cosine rules. So what the sine rule is about is when we have a triangle A, B, C, then this is angle A, angle B, angle C. Then the opposite sides, the side opposite this angle, we call it A, has a length A. The side opposite B, we call it small b, then C as this. So these are the size measurement, while these are the angles. So the sine rule establishes a relationship between the side, the length of the side and the angles, so that with that rule we can calculate any mistake. If a side is missing, when we have the other two sides and the angle included, then we can use such rules. For instance, the sine rule goes like the our A dividing it by its own sine equals B dividing it by its own sine, and equals C dividing it by its own sine. So it is saying that the ratio of a side to the sine of its angle, and the ratio of the side to the side of its angle are all equal. So if we know A and angle B and then side B, then we can equate these two to calculate A. Similarly, if we know, for instance, A and sine C, then we can determine C using by equating this to this. So that is what the sine rule is about. Then we have the cos rule, what we call the cosine rule. So in cosine rules, so we'll be using cosine of the angles instead. So in cosine rule, when two sides are known, then we can calculate the third side with the opposite angle given. You understand? So because every side has a corresponding angle, the angle corresponding to A is this, that of B is this, that of C is this. So if we are trying to calculate A, then giving B and C, then we can use this formula to calculate A. So which means the square of A is equal to the sum of the square of the other two sides minus then twice the length of the product of the length of the two. So that is 2BC. Then cosine of the angle of this. So similarly, if we are finding B, then with A and C knowns, then we have 2AC. The cosine of the angle opposite this side. So similarly, this is B. C square will be A square plus B square minus 2AB cosine of angle C. So these are cosine rules. So if you are giving B, C, and angle A, you can calculate A using this. By the time you evaluate this, then take the square root. You get it. Giving A and C, then you can, and angle B, you can determine side B. Giving A and B and angle C, you can determine side C. So these are the sine rules and cosine rules. So all these we are going to be using them in solving problems on bearing and distance, because in bearing and distance we'll be finding an angle. So we're talking about bearing. We want to know, the angle. When you're trying to locate a position, you're going to turn a certain angle from the reference point, and then you move a certain distance to a point. So that means we'll be talking about determination, calculating angles and distances. So that's the essence of introducing the topic with trigonometry. So reviewing this trigonometry, so you have to take note of all this formula, the cosine formula and the sine formula. Then you will know when you can use any of them. Supposing you have two angles given with a side, then the other side can be calculated using sine. It will be more convenient to use a sine rule. So, but when you have two sides, one angle, and you are calculating a side, it's more convenient to use the cosine rule. So in bearing, so we have this the cardinal point, the four cardinal directions: the north, the east, west, and south. So that we have to remember. And point located. what you have noticed is that the angle, the knot is always the reference point. Is the reference point. The knot is the reference point with angle of 0. So at this point you have a 0. Then moving to this point you have 90 degree. Then to the south you have 270 degree. Then coming back here, sorry, you have 180, because each of this is 90. Then coming back here you have 270 degree. Then coming back you have 360 degree. So the knot is always the reference, in the sense that when you're locating a place, you are locating a place with respect to a reference point. So our motion, we'll be moving, we'll be turning with respect to n, with reference to the knot. So our movement will be from the knot, then clockwise. We will move from the knot clockwise through whatever angle is specified. So supposing it is said as let's say point B, or let's just say, if they say B is 140 degree from A. So how do we locate B? So the reference point is A. So let's say this is A. Then if this is A, then this is the knot of the A. Then try to locate B with respect to A. Then you're going to move 140 degree from the knot clockwise. So this 140 degree will definitely be an angle that will end here, because angles between from here to here is 180. So from here to here is 90, meaning from here to here, 140 will be around here. We call this the first quadrant, the second quadrant, the third quadrant, the fourth quadrant. So we measure quadrant. A quarter of this is called a quadrant. So first quadrant, second, third, fourth, in the clockwise manner. So angles between 0 and 90 will be located here. The angle greater than 90 but less than 180, they will be located around here. Similarly, angle greater than 180 but less than 670 will be here, will be in the third quadrant. Then the fourth quadrant, angles greater than 270 but less than 360. So this angle 140 will be found in the second quadrant. So what we do, we move from the knot of A, then clockwise until we get to where we believe is equals to 140. So from there, from the origin, the middle here, then you draw a line through this. So this is set to be 140 degree. This is point A. So point B is located somewhere here. So if the distance is specified, then somewhere here you have B. So we can now see from here that point B is 140, or the bearing of B from A is 140 degree. Do you understand? So it's as good as saying that B, the location of B now, in terms of if representing the location of B, we can say B is located between the south and the east. You understand? So we can say B is south. How do you express it? It's located southeast. So it is located southeast. Then by what angle? The angle will be whatever is left here. From here to here is 90. From here to here will be 50. So we can say 50 degree southeast. So it will be easy for somebody now to locate this point. So okay, you'll be able to know that okay, the point is between south and east, and then it is when you move from here by 50, then you should have this. I hope this is understood. But actually, the bearing is 140 degree, which is measured from the knot of the reference point until the angle where the angle stops in whatever quadrant it stops. So another example is supposing point B is let's say it's 60 degree from A. So if this is your A reference point, then you move 60. 60 will be somewhere here. So this is 60 degree. So which means B is somewhere here from A. And supposing B is 290 degree from A. So you move from A, this is 180, 270, and 290 somewhere here. So B will be located somewhere here. So which means B lies in the northwestern part. You understand? It's a northwestern location. So this is how we draw bearing. This is how we locate points based on their bearing from reference point. So the distance, if specified, then they will represent the length of the line joining the 2 points. So this is as simple as that. So in the next video, then we'll start looking at problems concerning bearing. So then we start solving problems concerning bearing using what we have learned in the trigonometry and then some other stuff that we're going to learn. Thank you.